Welcome to the Explainer. Look, right now developers everywhere are pulling their hair out. We're dealing with massive latency, skyrocketing costs, and AI agents that are, frankly, incredibly flaky. We're kind of just throwing these massive language models at absolutely every problem we encounter. But the truth is, the industry is suffering from a fundamental architectural mistake. So today, we're going to fix that. We're going to learn exactly when you should use code and when you should use an LLM.
Okay, let's dive into this with a quick war story from the early days of AI engineering. Picture this. A development team spends weeks heavily engineering a prompt to read invoices. They literally wrote in all caps, "Output only JSON, do not say anything else." And, hey, for 3 weeks it worked perfectly. Then, over a weekend, the model output a single, completely hallucinated backtick. Just one backtick. And it brought down the client's entire automated invoice processing system. Why did that happen? Because LLMs are brilliant readers, but terrible, unpredictable writers. So that brings us to a massive question. Why on earth do we keep treating probabilistic text generators like deterministic APIs? There is this widespread false dichotomy right now that intelligence purely equals large probabilistic neural networks. But think about it. If a task requires strict predictability, why are we handing it over to a system that essentially guesses the next word based on probability? It is quite literally like asking a poet to do your taxes. It just doesn't make sense.
And the business consequences of this mismatch? They are severe. Get this. Gartner predicts that over 40% of agentic AI projects will be canceled by the end of 2027. The hype around autonomous agents is just drastically outpacing the actual governance infrastructure required to run them. Escalating costs, massive latency, and overall unreliability are just killing these projects before they ever generate any real value for the business.
But it's not even just a reliability issue. It's a massive security threat. Open-source AI code generation hallucinates package names at a staggering 21.7% rate. And trust me, attackers know this. They actively hunt for these hallucinated package names and then register them with malicious code. It's a technique known as slop squatting. So, in a security pipeline, this variance isn't just an inconvenience. It literally turns your AI into an automated supply chain attack surface.
Section 1. The Core Decision Framework. Stop begging models to output JSON.
The truth is, most intelligent systems out there don't actually need more AI. What they need is better architecture and a highly disciplined decision framework. So this brings us to the ultimate mantra of this explainer, the one golden rule you absolutely need to take back to your teams. If the task has a clear answer, enforce it with code. If the task has fuzzy language, use an LLM. And if the task is risky, combine both. This gives you a real, actionable framework instead of just vague AI advice. Use code for certainty, use LLMs for ambiguity, and use both when the workflow matters.
And this brilliantly illustrates the divide between these two paradigms. On the left, you've got deterministic code. It's exact, it's testable, it's blazing fast, and it relies on strict rules. On the right, probabilistic AI. It's incredibly creative, handles ambiguity like a champ, and recognizes complex patterns. But its outputs are always going to vary. Business operations, think payroll, compliance, database updates, those are deterministic by design. Generative AI is probabilistic by nature. We absolutely have to match the right tool to the task.
Section 2. Enforce certainty with code. The limits of probabilistic models and the temperature zero myth. Any task that requires exactness absolutely must be handled by deterministic code. If you don't do this, you end up paying what systems engineers call the unreliability tax. That's the massive overhead you need just to mitigate system failures and weird logic loops. Now you might be thinking, well, I just set my LLM's temperature to 0, so it's deterministic now. Actually, no, that is the temperature zero myth. Under the IEEE 754 standard, floating point addition on parallel GPUs is not associative. Think of it like shuffling a massive deck of math problems across different processors. Because of varying thread schedules across cores, the physical order of operations changes under the hood. This causes tiny rounding differences or logic shifts. So even at temperature 0, this shift can alter the selected token and change your entire generation path. No way, right? But it's true.
Because of that underlying non-determinism, anything causing legal, safety, or data integrity issues must be enforced in code. This includes exact validation, math calculations, business permissions, and ID matching. You should never, ever rely on prompt engineering to beg a model to do these things securely. They belong in code, where the same input yields the exact same output every single time. For sure.
Section 3. handle ambiguity with AI, using the right model size and architecture for the job.
Now, we're not saying get rid of AI. We just want to use it efficiently for what it's actually good at, which is interpreting messy text. Now, what's really interesting about this breakdown is the architectural difference. If you have a narrow, well-defined task like classification, a small language model, or SLM, can run in milliseconds on a standard CPU. Plus, for classification, you can use an encoder-only architecture. It processes the input in a single forward pass and returns a deterministic output. Contrast that with massive LLMs, which are decoder-only. They generate text sequentially, which wastes compute and adds huge latency when literally all you needed was a simple label.
The power of these fine-tuned SLMs is just incredible. To put this into perspective, a 205 million parameter model called Gliner-2 runs on a basic CPU, and it actually matches GPT-4o on specific named entity recognition benchmarks. GliGuard, at just 300 million parameters, is 16 times faster than frontier models for safety moderation. ServiceNow even found that their fine-tuned SLMs beat prompting massive LLMs when it came to structured workflow generation. For token-level extraction, a fine-tuned encoder routinely matches generalist models 90 times its size. It's a real game changer.
Section 4. The Hybrid AI Architecture, the Symphony Orchestra Model.
In this model, your deterministic code acts as the conductor. It maintains absolute control over the workflow, while your AI models are the musicians executing highly specific localized roles. Let's walk through this 5-step production pattern. Step 1, ingest the input. Step 2, your deterministic code validates and normalizes the structure. Step 3, the LLM is deployed purely to interpret and transform the messy text. Step 4, code steps right back in to verify the output against strict business rules. And Step 5, if confidence is low, you escalate to a human. The key here is that the probabilistic model operates entirely inside a deterministic scaffold.
Let's ground this in a real-world case study. Remember our invoice processing nightmare from earlier? Here is how you do it right. Your deterministic code checks the file types and verifies the arithmetic of the totals. Then, the LLM is used to read the messy free-form vendor text and notes. Once it extracts that data, your code takes over again to enforce internal accounting rules and thresholds. If anything flags, a human reviews the edge case. This division of labor is incredibly reliable, and it guarantees a rogue backtick won't take down your whole system.
Section 5. Reliable AI